Next example, f of xy is equal to under root mod of xy. This mod, because of this mod, this function is defined for every ordered pair xy. Since this square root is defined for only non-negative numbers, this mod ensures this non-negativity of this product, and so this function is continuous. So we cannot show this f is discontinuous. Next, we will move to partial derivatives. We have fx at 0, 0 is equal to limit of f of h0 minus f of 0, 0 upon h as h tends to 0 is equal to f of h0 is 0, f of 0, 0 is 0 upon h. This means fx at 0, 0 is 0. So again fx exists, we cannot use necessary condition for differentiability. Now we find fy at 0, 0. In partial derivative with respect to x, we change x. In partial derivative with respect to y, we change value of y. Again this will be 0. So both exist, so we cannot again use necessary condition for differentiability. So we have one option, which is definition of differentiability. For you to use definition of differentiability, suppose that f is differentiable at 0, 0. Therefore f of 0 plus delta x, 0 plus delta y minus f of 0, 0 can be expressed as fx at 0, 0 into delta x plus fy at 0, 0 into delta y plus epsilon 1 into delta x plus epsilon 2 into delta y, where epsilon 1 tends to 0, epsilon 2 tends to 0, as delta x, delta y tends to 0, 0, by using definition of differentiability. Now this 0 plus delta x will be delta x, 0 plus delta y will be delta y. Therefore f of delta x, delta y, f of xy is under root a mod of xy. Therefore f of delta x, delta y will be therefore under root mod of delta x, delta y minus f of 0, 0 will be 0. So no need to write. We have already found out fx at 0, 0, which is 0, 0 into delta x plus fy is again 0, 0 into delta y plus epsilon 1 delta x plus epsilon 2 delta y. That means epsilon 1 delta x plus epsilon 2 delta y. And left hand side is mod of delta x into delta y. Now we have to use the technique we have used to show limit does not exist. What we can do here, take paths in terms of delta x and delta y. Like along x axis y is 0, but here we have to take delta y is equal to 0. Suppose delta y is equal to 0, left hand side becomes 0, right hand side becomes this term 0, epsilon 1 delta x, and then apply limit, but limit of epsilon 1 is 0 again, so left hand side is 0, right hand side is 0. So we don't take this path delta y is equal to 0. Now we take delta x is equal to 0. When delta x is equal to 0, left hand side becomes 0, right hand side becomes epsilon 2 delta y, and then we apply limit, and after applying limit this will become 0. So we will get 0 is equal to 0. So we cannot take this path delta y equal to 0. Now we take path delta y is equal to m into delta x. So left hand side will become mod m into delta x square. As there is a square, so no need to write in mod, under root. On the right hand side we will get epsilon 1 delta x plus m into epsilon 2 delta x. We will take delta x common and we will get epsilon 1 plus m epsilon 2 into delta x. Then at the left hand side, under root mod m, and this will be delta x. So this delta x and this delta x will get cancel, and we will get under root m is equal to epsilon 1 m epsilon 2. Now we will apply limit. We will get under root mod m. Here this limit of epsilon 1 is 0, this will be 0, so we will get under root mod m is equal to 0, and we will take restriction here, m is not equal to 0, so we will get contradiction, and contradiction will prove that f is not differentiable. So we are considering put delta y is equal to m into delta x. M is, you can take positive also, we need m is non-zero. Instead of m non-zero we will take m greater than 0, so we can easily find mod m. Mod m will be m only. We will get here on the right hand side mod of m into delta x square. This will be not right hand side, left hand side. On the right hand side we will get epsilon 1 delta x plus m into epsilon 2 delta x. On the left hand side we will get under root, this will be mod m will be m. As this term is square, so no need to write in mod. So mod is, m is positive and delta x square is non-negative, so no need to write in mod. We will write only m into delta x square. On the left hand side we will take delta x common. Here we can take delta x square's square root, so which will be delta x. This square root and square will get cancel, is equal to epsilon 1 plus m epsilon 2 into delta x. Now delta x will get cancel, and we will get under root m is equal to epsilon 1 plus m epsilon 2. Therefore limit delta x tends to 0. Why delta x tends to 0 only? Not delta x tends to 0 only. We will take limit delta x delta y tends to 0 0. Or no right to delta x delta y tends to 0 0, since delta y is equal to m delta x. As we have already put here delta y in place of delta y m into delta x. So function is only of delta x. So we will take limit as delta x tends to 0 under root m is equal to delta x tends to 0 0 epsilon 1 plus m into epsilon 2. Now as delta x tends to 0, using this we can say delta y also tends to 0. If we put delta x 0, delta y becomes also 0. So delta x, and as delta x delta y tends to 0, using this, as delta x delta y tends to 0 0, epsilon 1 epsilon 2 becomes 0. So here we can write delta x delta y tends to 0 0. Why we can write this? Because delta y is equal to m into delta x. Then using this, first this limit will be 0, and on the left hand side limit of root m will be root m only, because this term is independent of delta x, and which is contradiction. because m is not equal to 0, so its square root is not equal to 0. So this contradiction proves our supposition is wrong. What is our supposition? F is differentiable at 0, 0. Therefore f is not differentiable at 0, 0. F is not differentiable at 0, 0.